For this data set, we are required to draw a box diagram to represent this data. Now, first things first would be to write them from smallest to biggest. So we will start with 1, then there's a 2, then there's a 3, then we have 3 4s, so we'll write them down 3 times, then there's a 5, then 2 6s, also write them down, both of them, then there's an 8, then 13, and lastly the 17. And then we need to find the median, or the term right in the middle. Now there are 12 terms, so we can see that in the bottom half there would be 6 terms, in the top half there would also be 6 terms, so right in the middle between 4 and 5, or 4.5, we'll find the median, or Q2. To find the lower quartile or the median of the bottom half, we'll do exactly the same. Right there between 3 and 4, namely 3.5, will be our lower quartile, and for the upper half we'll do the same thing. Between 6 and 7 and 8 there is 7, that will be the upper quartile. And then to find the interquartile range, we simply say Q3 minus Q1. That gives us 7 minus 3.5, which is 3.5. Now we'll use this a little bit later on. For the time being, it's just information that we calculated while we are working with the quartiles, the upper and the lower quartiles anyway. Now to draw the box diagram, we need to create first of all just a straight line like that. We will have a minimum and a maximum value. Now the minimum and maximum is not necessarily going to be either the 1 or the 17, but we'll come back to that a little bit later. What we need first of all is to plot the quartiles Q1, Q2 and Q3. So we'll start with the 4.5 of Q2, plot that there, say that is 4.5 Q2, then we'll have Q1 and Q3. Now Q1 was 3.5 and Q3 was 7, and then we'll draw a box around the quartiles. Like that. Now effectively speaking, we are almost done with our box plot, because we have indicated where the majority of our data actually lies. Between Q1 and Q3 we've got the majority of the data. We however also need to indicate the minimum values, which will be 1 there, but now you have to be very careful. The maximum could be 8, 13 or 17, or maybe none of them. We need to find whether it's a maximum value for the data set or whether it can be represented as outliers. Now to find the outlier values, we say Q3 plus 1,5 times by the interquartile range. That's why we worked out the interquartile range before. Q3 is 7 plus 1,5 times by the interquartile range, which is 3.5, and then we get 7 plus and 1,5 times by 3.5 is 5,25, and that then gives us 12,25. So we have a cut-off point, if you like to call it that way, there of 12.5 or 12,25, 12.25. Anything bigger than that is considered to be an outlier. So we have our maximum, which is then 8. 8 is still below the cut-off point, and then we have the 13 and the 17 considered to be outliers. Now if you were wondering whether 1 is also going to be an outlier, you would have used the formula Q1 minus 1,5 interquartile range. But if you did this, you would have had minus answer, I think it's minus 1,75, which will mean that your cutoff point for minimums would be going into the negatives, and we don't have negative values anyway. So 1 is still safe as part of our data range, and it can be considered the minimum, and then 8 will be considered the maximum, and the 13 and the 17 are the outliers. Now, what is very important and nice about this type of box plot is, like we said before, you can see immediately where the majority of your data is concentrated, and you can see the outliers, which means these are really way off data peaks, something which doesn't form part of the norm. It's not something which is a regular feature in the data set, whatever this data represented. It's something which is not part of the normal features that we would associate with data such as this, and that's why they are called outliers, and you can identify them very quickly in this process and then decide whether you want to actually use them for your final data processing or not. So they are clearly identified: number one, your outliers, and number two, the majority of your data as well.